Hi everyone. So today we're going to be learning about sound, and we're going to be doing a lot of comparison through this unit of light and sound. So this video is going to be kind of a compilation of the things that you learned in Monday's lesson and Tuesday's lesson. So the first thing that we want to do is talk about how sound is created. So in your presentation, there was a slide that asked you to put your hands on your throat, about right here. And as you talk or make a noise, what do you feel?
You feel vibrations.
Exactly. So that vibration is what is creating your sound. So sound is created by vibrations. So we're going to go ahead and take a look at that. I'm going to ask Avery to help me to demonstrate a couple things here. Hi, Avery. So the first thing I want you to do, Avery, is pick up a tuning fork.
Doesn't matter which one.
No. So we have 3 different tuning forks here, and these tuning forks are made of metal, and the way that they work is by hitting them against another solid, and when you hit them against another solid, they produce vibrations. Can you go ahead and... So when they produce that vibration, what did they also produce?
Sound.
It produced sound, and depending on the different lengths of your tuning forks, it will produce different sounds. Oops.
That one made vibrations.
Okay, so can you go ahead and hit a different one and produce some different sound? And we call those different sounds pitch. We're not going to go into a whole lot of pitch, but these are actually what musicians use to tune pianos or tune different instruments. And if you look closely on each of those tuning forks, there's a letter on them. And this one is C.
This one's also C, but an octave higher.
Okay, see, she knows music better than I do.
This one's a G though.
And then that one's a G. So each one of them produces a different sound. Now, when we talk about vibrations, we know that sound travels in all directions. So when we produce the vibration, instead of just traveling in a straight line like light does, the vibrations go out in all different directions, which is why if I turn my back, Avery, can you still hear me?
Yeah.
So that vibration, my sound, is traveling in all different directions. Now what I want you to do, Avery, is take one of those tuning forks and put it in the water. And what should happen, you want to get a little bit closer here. Hi, Aiden. What should happen here is the water is going to scatter in all different directions, proving that those vibrations are moving not just straight ahead, but in all different directions there. So the next thing that I want to do, so again, sound is made by vibrations, and vibrations travel in all different directions. Avery, the next thing that I want you to do is we're going to demonstrate one of the labs that you're supposed to do on day 2 or on Tuesday. So what you need for this lab is a metal hanger and some string. Probably want the string to be about 2 feet long. And you want to wrap that string around your fingers like Avery is doing. So Avery, first I want you to just hit the metal hanger against the side. So here we hear just like a tiny little click, 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 click. But what I want you to do right now, and so the sound right now is traveling from the metal hanger through the air to our ears. When Avery puts her fingers in her ears, number 1, she's going to look kind of silly. But number 2, when she hits the side here, the sound is going to travel from the solid hanger to the solid string through her fingers, which are also solid, and into our ears. Can you describe the sound that you're hearing now?
It's a lot louder.
It's a lot, yeah, I kind of think that it sounds like
a doorbell.
A doorbell or bells gonging, like church bells, if you've ever had church bells. It's really, really loud when you do that. So unfortunately, you can't hear what Avery is hearing right now, but if you have those materials, please try and do it, because it's a really significant difference in the sound. And I want to talk about why. So Avery, can you take over the phone? Oh, they're trying to be silly over there. So I want to kind of draw for you. Can you hold this? What molecules look like in the solid, liquid, and gas. And you'll see a slide on Tuesday's presentation also. But when you look at, if you could see the molecules inside a solid. Inside a solid, you have molecules that are really, really, really closely packed together. And what you might not know about the molecules inside a solid is that they're actually moving, but they move a really, really tiny bit. They just vibrate back and forth here. When you look at the molecules inside a liquid, the molecules, the molecules are spread further apart, so they can move a little bit more freely in a liquid. In a gas, the molecules are really far apart and they can go wherever they want. The liquids are going to stay within that container that they're in, and then solids obviously stay within that solid. So when I want you to picture sound like a little person. So picture a little person on top of each of these little molecules here. Well, there's my little stick person. And think of them having to travel, because we know, let's think back on light. Light does not need a medium to travel through. So remember, a medium is a solid, a liquid, or a gas. So that's why we can see the light from a star, the light from the sun and other stars, is because that light does not need a medium to travel through. Sound, on the other hand, has to have a medium to travel through. It has to have a solid or a liquid or a gas. So the sound will latch onto a molecule and then has to travel from one molecule to the next. So as the sound is traveling, in a solid, the molecules are really close together. So it's really easy for this sound molecule to travel because those molecules are so closely packed together. Think about a stream. And if you've ever been on a stream, if you're trying to get across a stream and you have to jump on rocks. So if those rocks are really close together, it's really easy to travel from one to the next. But if you were in a stream where the rocks were further apart and they're actually moving, think about how hard it would be to travel from one molecule to the next. It would take you a lot longer to travel through that liquid area than it would for the solid. So that solid is going to produce sound a lot better, or a lot louder, I should say, than a liquid. And then when you look at the gas molecules are even further apart and they're moving even faster. So picture yourself trying to jump from one molecule to the next. It would be much harder to do that. So it's when when sound is traveling through a gas, it's much harder for that sound to travel through, which is why the sound is is less quiet, or more quiet, I should say. The other thing that you can try if you can't do the hanger one is to do this. So if you're going to stand in front of any kind of solid and I want you to just tap on it and hear the sound. So that sound is traveling from that solid up into your ears, but in order to get to your ears, it has to travel through gas. So remember that it's hard for that molecule to travel because those gas molecules are so far apart. But then what I want you to do is put your ear on the table or whatever it is. Even right now, I can hear my voice so much louder when I have my ears to this table. I'm not talking any louder, but it sounds louder. Then go ahead and tap. Tap up here, tap down here. Which one sounds louder? The sound is going to be produced much louder when it's going through a solid than it is when it has to travel through a gas. I think that's all. So sound is made through vibrations. Sound travels in all directions, which is why if you turn this way, you can still hear the sound even when you're over here. If I took a flashlight, just happen to have one here, when we're talking about the comparison between light, oh, it's too bright in here, but that light only travels in one direction. So you would only see it going that way. You would not see it in this direction. So sound is made by vibrations. It travels in all directions. Solid, it's going to travel the fastest because the molecules are closely packed together. Liquid, it will travel more slowly. And then gas, it travels the slowest through, which will produce a quieter sound. Let me just double check, make sure I covered everything here before you end this, Avery. And I think that's it. Okay, that's it for Monday's lesson and Tuesday lesson summary.